Okay, troops, we're going to do a little walkthrough of the 2019 Higher Physics multiple choice paper, questions 1 to 16. There's 25 questions in the multiple choice. We're going to have a look at the stuff in Unit 1. Unit 2, your data sheet is the first thing you'll come across, and that first table is pretty much all you will need. It's got everything in it for certainly all the questions we're going to be looking at. The other two tables, not much use for them, certainly at the moment. So in an exam you would no doubt get a multiple choice grid or an answer booklet to put your answers in. It'll be the sort of thing you have seen numerous times before, but 25 questions in the multiple choice, and don't forget that you would highlight the letter corresponding to the correct answer. If you make a mistake, cross it out and then highlight your correct answer. Most important thing with multiple choice questions though is don't try and do them in your head. Use as much scrap paper as you need to carry out calculations or do any working. That scrap paper just gets thrown straight into the bin, but don't try and do it in your head. Use as much paper as you need. Right, let's go. Let's jump in with question 1. Now you might want to pause it before I actually do the question so you can have a go at it yourself. I'm going to put my working and my answers on the paper. I'm not going to use a grid, just so that you can see what I'm doing. So this is question 1. The first 10 questions are from our dynamic universe, and this first question is asking for the average speed of a car during its 12-second journey. Remember to pause this if you want to try it before I do the answer on the paper. So here's how I would have a go at this. Average speed is just the average of its initial speed plus its final speed. So 15 plus 10 divided by 2 is 12.5 meters per second. That corresponds to answer E. You could, of course, also have done this question by working out the area under the graph. The area of the rectangle is 120. The area of the triangle is half the base times the height, which is 30. So the total area is 150. That's the total distance gone. So average speed, distance over time, 150 divided by 12, 12.5 meters per second. Same answer. Moving on, question 2. This looks like a projectiles question, and we are asked which row in the table gives the horizontal and vertical components of the initial velocity of the stone. So we're going to draw a right angle triangle, put in our angle of 50 degrees and our hypotenuse of 15. And our components, remember the horizontal component is the adjacent side of the triangle, so cos for a cross, that'll be 15 cos 50, and sine for the opposite side of the triangle, so 15 sine 50 for the vertical component. How does that match up with the table? Well, horizontal is cos. We've got 3 to choose from, no, 2 to choose from there, so it could be B or C, but 15 sine 50 for the vertical, which means the answer is B, 2B. Question 3 is another projectiles question. We're asked for the speed of the ball just before it hits the ground. So it will be the final speed of the ball. So we know its horizontal speed is constant. It's 40 meters per second horizontally. And its final speed is minus 30 or 30 downwards just as it hits the ground. So again, we're going to draw a right angled triangle. Put in the horizontal component, which is 40, the vertical component, which is 30 downwards, and we have a 3, 4, 5 triangle. The hypotenuse will be 50 meters per second. Now the question asks for the speed of the ball just before it hits the ground, so we don't need the angle, it's just the magnitude, so 50 meters per second, it's D. Question 4, we're asked which pair of graphs represents the motion of the car. It's a car that's got an acceleration that is constant. Constant acceleration means the acceleration time graph will be a horizontal straight line. So it could be A, it could be C, it could be D. Remember, in multiple choice, you can narrow down your choices. So if we narrow it down to A or C or D, we can always have a guess if we're not sure. But let's think it's accelerating, so the displacement will be increasing at an ever-increasing rate. So graph A is correct. So therefore, for question 4, it's A. Now question 5 is about coupled systems or tension. We have a system there that's moving to the left. There's a force accelerating it to the left, and we are asked to compare the tensions P, Q and R. Tension P is pulling a total mass of 70 kilograms. R is only pulling 40 kilograms. So P will be the greatest, R will be the smallest, and therefore our answer is B, greatest in P and least in R. Our answer is B. This is a constant force and a frictionless surface, so unbalanced force to the left causing the acceleration. Question 6 is a triple statement question. That means you have to check which of the following statements is or are correct, and I would suggest you tick these if you're sure they are correct and put a question mark beside them if you're not sure. So it's an elastic collision. Total momentum is always conserved and total energy is always conserved, and in the case of an elastic collision, the total kinetic energy is also conserved. So in this case, it's all three, and it's E. Let's move on. Question 7. The unknown equation question. Somewhere in your higher paper, you will get a question with an equation that you've never seen before. But don't panic. All you have to do is put the numbers in or rearrange it a wee bit, and it's number crunching on your calculator. In this case, we're asked a question to find the area of a skydiver. Now, we're given a lot of information there about various symbols, and the one we are looking for is area, which is a capital A, which is on the bottom line of the right hand side there, and it's also inside a square root sign. So the first thing to do here is probably square both sides, and that will get rid of the square root sign. So v squared equals 2mg over that curly p times A times CD, whatever that stands for, drag coefficient. Now we're rearranging to try and find A. So A is the subject of that relationship. So we're just really swapping the A with the v squared. So 2mg over curly p v squared times CD, and then we're just putting the numbers in. So A equals 2 times the mass was 95. G is 9.8. Yep, it's on Earth. And that's all divided by curly p, which is density of air, 1.21, times V, which is 44, and don't forget to square it, because it's V squared, times the drag coefficient, 1.0, not 1.1, 1.0, and I would put brackets around all that in my calculator. Gives me an answer of 0.7948 ... on my calculator. Does that match any of the answers? Yes, it does. 0.79. It's B. Now watch out when you're doing this sort of unknown equation question. Quite easy to be caught out here. Don't forget to square the V in this case, because if you don't, you're going to end up with 34.9735, which is one of the other answers. So double check. It's B. Question 8. Spacecraft travelling very fast A technician measures the length is 275 and it's observed to have a shorter length. So this is special relativity. We have to go to our relationship sheet and find the length contraction relationship. So relationship sheet is down at the bottom there. There we have, it's the L dashed relationship. And so let's make sure that when we do our rough working, we copy that relationship down. And this is particularly tricky this time. We can substitute in for the observed length and the proper length, but it's V that we're looking for, so we've got a bit of rearranging to do here. Let's divide both sides by 275 and square both sides, because that will get rid of the square root sign. And then do the left hand side on your calculator, and you should get 0.2. And if the left hand side is equal to 0.2, we can rearrange to get V squared over C squared on the left hand side. So that will be 1 minus 0.2, which is 0.8. So nearly there. V squared will be 0.8 C squared. We know that C is 3 times 10 to the 8. And if you square root your answer to that, we will finally get our V. And V will be equal to 2.68 times 10 to the 8. Now watch your rounding here. Very slight difference there. That's because I rounded the 0.2. Okay, question 9 is about redshift and Hubble's law. Remember, there's 3 relationships. Whenever you're dealing with redshift, let's go to the relationship sheet and see those 3 relationships. We're only going to need the bottom 2 for this question. So let's take those 2 relationships and let's jot them down beside the question. And we have to work out the distance of the galaxy from the Earth. So let's rearrange the first relationship. For D equals V over the Hubble constant. And to get V though, we have to rearrange the second relationship. V equals Z times C. We know what all those numbers are, so the redshift ratio is 0.014 times the speed of light divided by the Hubble constant, which you will find on your relationship sheet, 2.3 times 10 to the minus 18. Substitute that into your relationship. A lot of work here for 1 mark. Gives us an answer of 1.83 times 10 to 24. It's B. Very tricky. Question 10 is another triple statement question. Which of the following statements is or are correct? Remember, tick them if you're sure. Put a question mark if you're not sure. The force of gravity acts against the expansion of the universe. I think that's right. Measurements show that the rate of expansion of the universe is increasing. Yes, it is. And the mass of a galaxy can be estimated by the orbital speed of the stars. Yes, that's a fact that's straight out your content statements. So all correct, 1, 2 and 3. That's 10 questions from the Our Dynamic Universe unit. Very tricky. Hopefully it'll get a bit easier. This is question 11 from Unit 2. Particles and waves. We're asked about the voltage across 2 plates P and Q. We're told what the charge on an alpha particle is and the kinetic energy that it gains. Well, the kinetic energy it gains is the same as the work done on the particle by the field. We're going to use the relationship W equals QV and rearrange it for V. V equals W over Q. The work done is equal to the kinetic energy. That's 8 times 10 to the minus 16. Divided by the charge on the alpha particle, 3.2 times 10 to the minus 19. That gives us an answer of 2,500 volts. and 2500 volts is 2.5 times 10 to the 3. Answer D. Charges moving in magnetic fields. Question 12. What's the direction of the magnetic force on the electron? Well, we need to use our right hand rule here. And the magnetic field is coming out of the page. We're told that on the diagram. So using your right hand rule, your first finger should be pointing out of the page. Your second finger is pointing from left to right. And your thumb points up the way towards the top of the page. So the answer to question 12 is A, towards the top of the page. Question 13 is about the Standard Model. Okay, triple statement question. Not very sure about that first one. Every particle has an antiparticle. Alpha decay is evidence for neutrinos. No, it's beta decay that was the first evidence for neutrinos. The W boson is associated with a strong force. No, it's the gluon that's associated with a strong force. 2 and 3 are definitely wrong. That means number 1 must be correct. They can't all be wrong, so 1 only. 13A. 14. Nuclear reactions here. Okay, we have a nucleus of francium, it looks like, 22387 Fr, and it emits a beta particle. And we're asked to find the nucleus that is formed as a result. So let's write this out. There's our beta particle. It's got a charge of -1 and its mass is negligible. And let's balance the sum either side of the arrow. So A must be 88, B must be 223, and the element X we would have to look up on a periodic table, I suppose. Now, you do have a periodic table as part of your relationship sheet booklet that you have. But in this case, we don't need to look up the periodic table because there is only one of the answers that has 88 and 223. So we don't need the periodic table. Our answer is, which one's 88 and 223? It is C. Right, moving on. Question 15 is the photoelectric effect. There is light shining onto a zinc plate, and we are asked which graph shows the relationship between the current in the circuit and the frequency of the incident radiation. Well, remember, below a certain threshold frequency, no current flows. And that current will increase as the frequency is increased because the electrons will be ejected with more kinetic energy. That means the electrons will be moving faster, and that in turn will contribute to a higher current. Question 16 is also photoelectric effect. We're asked about the maximum speed of a photoelectron. Well, that will relate to its kinetic energy, and kinetic energy is equal to the energy of the photon, hf, minus the work function of the metal. And both of those quantities are given in the question. 6.4 minus 4.2 is 2.2 times 10 to minus 19 joules. Now that's the kinetic energy of the electron. We still have to work out what its velocity is. So we rearrange the kinetic energy equation to get V squared. So V squared will be equal to 2ek over m. And if we square root both sides, we end up with V equals the square root of 2ek over m, and substitute in for our values, I end up with 6.95 times 10 to the 5 meters per second, and that corresponds to answer C. Don't forget, in this one you had to look up the mass of the electron on your datasheet. which is 9.11 times 10 to the minus 31 kilograms. Don't forget your data sheet. Right, so we're going to finish there with question 16 just now. That takes us up to the end of the particles content in the particles and waves unit. We will return with part 2 later on in the year with the rest of the wave stuff and the unit 3 stuff on electricity. See you in a bit.